Good morning, children. Today we will discuss about quantization. Let us go with the presentation. Quantization. So already we have discussed about sampling which is related to the coordinates values, and quantization which we are going to discuss, which is related to the intensity values. Sampling related to the coordinate values, quantization which is related to the intensity values. Now, if you consider the digital signal, if the amplitude is in the state of discrete, that means amplitude is in discrete, that means we cannot choose any value of the amplitude, it has only a fixed value. If you consider the amplitude in the discrete, means in the digital signal we cannot choose any value of the amplitude, it has a fixed value. Now let us discuss about the basics of quantization, and this is the circuit diagram, and here we have the analog signal which is represented in x of t. So here this analog signal which is the time continuous, amplitude also in continuous. Analog signal time is in continuous and amplitude also in continuous, and analog signal which is represented in x of t. And here next it is sampling. So by using this sampling we can translate analog signal into the discrete signal. We can translate analog signal into the discrete signal by using this sampling. Now let us see the example for this analog signal, and here we consider analog signal x of t equals to sine 2 pi ft. X of t equals to sine 2 pi ft. Here amplitude is continuously varying with respect to time. Already we have seen time is here amplitude is continuously varying with respect to time. So here in the case of analog signal, amplitude is continuously varying with respect to time. That means here where t equals to 0.1, 0.11, 0.112 and so on. So here if it is in continuous mode, that means any time period we can choose. But if it is in the state of this discrete value, we cannot we have to choose a fixed value. Okay, so here amplitude is in continuously, which is vary with respect to time. So t value either it may be 0.1 or 0.11 or 0.112, so on. Now let us see the discrete signal, and which is represented with x of x, which is equals to sine 2 pi f n ts. Here n is number of samples. N represents number of samples where n equals to 1, 2, 3 and so on. So here discrete signal which is continuous. If you see discrete signal is continuous in amplitude, and here to store it somewhere in digital system, it is compulsory to map that amplitude with the fixed magnitudes. For that we do the quantization. So after sampling we have discrete signal. Now let us see this one. So we have seen about the sampling with the time and discrete signal, and we have seen analog signal. And here after this sampling, if you see, so this is a circuit. We have the analog signal, and here sampling which converts this analog signal into the discrete signal. And here after this sampling we have the discrete signal. This is the discrete signal. And again here we have the quantization. So after this quantization we have digital signal. So here input of this quantization, here we have the discrete signal, and output we will obtain here digital signal. And here we have the digital signal. So here we have input which is discrete with respect to time. So input of this quantization, if you see, here it is input where here time is in discrete, and also amplitude is in continuous. So here input time is discrete and amplitude is continuous with respect to time. So here if you see the output of this quantization, we have the time in discrete and amplitude in the discrete. So both are in discrete, but in the case of here input of this quantization, we have time is discrete and amplitude is in continuous mode. And here in the output of this quantization, we have time is discrete and amplitude is discrete. Both are discrete. And here the output of this quantization, here it is in digital signal, and input it is in discrete signal, and which is represented with x of x. And here And in the quantization at outside already we have seen the digital signal which is having time is in discrete and amplitude also in discrete. And here whenever we have in the case of digital signal, so it is in the state of discrete. That means we cannot choose any value of the amplitude. There are the fixed values of samples. So there is so that is there in discrete amplitude as well. So here we cannot choose any we cannot choose any values, but we have a fixed values for this amplitude. Because of amplitude it is in discrete with respect to time. And here next we have the coding, having the digital data coding which is having the digital data. Now let us discuss what is quantization. So let us see what is quantization. So in quantization already we have seen output side will be having the digital signal. So digital signal already we seen. So time is in discrete and amplitude also in discrete. That means here we cannot choose any value of the amplitude. So there have we have the fixed values of samples. So there is in discrete amplitude as well as we have the discrete time. So coding we have seen digital data. So let us discuss what is quantization. So already we have discussed about the sampling. So here also we have in the circuit. If you see in the circuit also we have after the sampling, we have the quantization. So after sampling, we have discrete signal, and after quantization also we have the digital signal. So input is in discrete with respect to time, but continuous with respect to amplitude. Already we have seen the uh, circuit diagram. So output of the quantization it is discrete in time and also discrete in amplitude. Now let us see the diagram. So here this is the diagram for the quantization. Now let us consider a sine signal. So here let us consider a sine signal. So this is the sine signal. So here we have continuous input signal, analog signal. We have continuous input signal, analog signal. So here when you do sampling with respect to time. So already we have the sampling. So here these are the samples here these are the samples. So when you do the sampling, so here these are the samples when you do the sampling of this with respect to time. So here this is the signal, discrete signal by the lines. Here I have placed these are the samples. So this is the discrete signal. Discrete signal. Now, so how to quantize it? So we provide the discrete amplitude. So here we have the discrete amplitude. So to define the discrete amplitude, we have to see the beat depth. Beat depth here we have to see. So delta value which is equals to x maximum minus x minimum by L. Here L is equals to 2 power n. So if you see, observe in this figure, so the straight lines which are here with blue color, so those are the sample values, and here this is the curve, so which is a quantized value, and here this is the signal. Now let us see the delta value here. Step size of this delta, which is x maximum minus x minimum by L, where L equals to 2 power n. So here if we consider n value 2, that means 2 power 2 equals to, here we'll have 4 levels. So n is equals to 2 bit. Here we'll consider n value 2 bit. Now let us see. Let n equals to 2 bit. So number of quantized levels 2 power n. Here n is here we have 2. So 2 power 2. So total quantized levels we have here 4 levels are there. So if you consider here n equals to 2 bit, so number of quantized levels we have 2 power n. So total 4 levels we have. So that is we are defining by 4 levels here. So here if we consider, so here we have the values. Here the center line which is 0. So above the 0 we have 0 0.25, 0 0.5, 0 0.75 plus 1, and below this 0 we have the negative values minus 0 0.25, minus 0 0.5, minus 0 0.75, and here it is minus 1. So number of quantized levels we have 2, no, 2 power n. That means 4 levels we have. So here we will consider we have 4 levels. Now let us see this value here. So total we have 4 levels. So we are defining 4 different levels here. So range we have minus 1 to plus 1. So here we have range -1 to +1. Range here we have -1 to +1. So we have four different levels. So which are represented with 0, 0, 0, 1, 1, 0, 1, 1. So because of here quantized levels which is 2 power n, that is equals to, here we have considered n 2 bit, that means 2 power n, which is 4 levels. So total quantized levels here we have considered 1, 2. So this is one level at -1, and at minus 0.5, at 0, at 0.5. So we have considered here four levels because quantized levels are four. And here we have chosen here 0.05, the level here we are considering the amplitude interval here 0.05. Why we will show, I will show you here. So only these are the reference levels. Just we have, because we have four different levels. So we have considered here 0, 0, 0, 1, 1, 0, 1, 1 levels, which is what we can define after quantization here. So step size delta, delta equals to x maximum minus x minimum by L. So L value already we got, L equals to 2 power n, which is 4. So we have four levels. So here maximum range value here -1 to +1. So we are amplitude interval here 1 minus -1. So 1 plus 1 by 4, which is equals to zero point 0.5. So amplitude interval here we have considered this one, amplitude interval we have considered 0 0.5, and we have considered four levels with 0, 0, 0, 1, 1, 0, 1, 1. So amplitude interval we have find out by using this formula, delta equals to x maximum minus x minimum by L. So x maximum we have considered 1, x minimum we have considered -1. So this is the amplitude interval which we got 0 0.5. So in this case 0 0.5 we have considered the this amplitude interval. So after 0 0.5 amplitude interval, we have defined all those levels here. Now let us see. So whatever the discrete amplitudes that the nearest values here we will choose. Now let us see the amplitudes. So here we need to see what is that nearest value, and we have to include here the sample that will be zero value. Now sample value we will consider here 0, 0 0.707, 1, 0 0.707, 0, minus 0.701, -1. So these are the sample values and quantized values. So here we have to consider the quantized values which are nearer to this values, these values. The quantized values we have considered which are nearer to these values. So that is here we have to see. So digital signal already we have chosen 1, 0, 0, 1, 0, here 0, 0, 0, 1, 1, 0, 1, 1 for -1, and at this particular values for the particular samples already we have considered these digital signals 0, 0, 0, 1, 1, 0, 1, 1 already we have placed here in this one at this particular values. And quantized error, so we have to consider this quantized error from we will obtain this one by subtracting the quantized signal with sample signal. So we will obtain the quantized error by subtracting quantized signal from sample value. So quantized error represented with EQ, which is equals to XQ minus X. So usually we don't calculate error in positive or negative. Error is always in positive. So here we will obtain this one. Now let us see how we will draw the quantized value. So we have to consider the nearest values. So here, if you consider the sample value and these quantized values, so here let us see. So here we have 0, x sample 0, quantized value 0. Now let us draw here 0, at 0 we have drawn here, and next value we will see 0.707, and quantized value it is 0.5. So here we have considered only four levels 0, 0, this -1 and 0, 0. Here we have considered only four levels. minus 1, 0.5, 0, 0.5. But we here in the sample signal we have 0.707, but we don't have this level here. We don't have this level 0.7. We don't have level. Only we have considered four levels, which are given the name here 0, 0, 0, 1 level, 1, 0, 1, 1 level. But we don't have 0.7. So here in the case of sample value we have 0.707, but which is nearer to the 0.5. So we have to consider 0.5 value. So here, see. So 0.7 we did not consider that one, so we have considered here 0.5. So here we have drawn from here to here. So this one we will draw. So here we have considered from here to here. And again next value we have 1, sample value 1, and we don't have 1, so we have only 4 levels here. Already I told you 1, 2, 3, 4 levels, but 1 we don't have level, so it is nearer to 0.5. Again we are drawing 0.5. So we have drawn. So next sample value 1. Okay, next sample value 0.707. Again it is nearer to 0.5, and for 0 we will draw 0. So here see. So again we have considered this one, which is nearer to 0.5, and for 0 again we have to draw 0, and we are drawing the lines. Next one we have, next sample value we'll see, minus 0.701. So we don't have minus 0.701, and it is nearer to minus 0.5. Let us see. Minus 0.75, we don't have any level here. We have level which is near 0.5. So here we have only 4 levels, because L equals to 4 quantized levels. So we have 0, 0, 0, 1, 1, 0, 1, 1. So we don't have 0.707 value, so which is near to this one. So we will draw this one. So from 0 after we have drawn this one. So we are drawing the line. Again we have next sample value minus 1. So minus 1 we have minus 1. So here we have a minus 1 level. So we have drawn minus 1 level like this. Like this we will draw. So by using the sample values, we have to draw here quantized values. That means the nearest value we have to see, we have to check the nearest value for the particular sample value for to draw this quantized levels. So these are the quantized values, and these are the samplings we have. So this is about the quantization. So error, here we have to calculate error from subtracting sample value, quantized value to the sample value, and here error, we don't calculate error in positive or negative, just error it is always in positive. So this is about quantization.